It began as nothing more than a tiny point of light. Against the endless background of distant stars, the object looked ordinary, easy to overlook, almost invisible. But as astronomers continued tracking its motion, one remarkable fact became impossible to ignore. This object wasn't orbiting the Sun. It wasn't returning from the distant edge of our solar system like a familiar comet. Instead, it had arrived from the vast darkness between the stars. Officially named 3I, Atlas, it became only the third confirmed interstellar object ever discovered passing through our solar system. Unlike planets, asteroids, or ordinary comets, this traveler formed around another star long before Earth even existed. For millions, perhaps billions, of years, it wandered through the Milky Way before chance carried it into our cosmic neighborhood. Immediately, observatories around the world turned toward it. Ground-based telescopes began measuring its brightness and motion, while powerful space observatories searched for clues hidden within the light reflected from its surface. Every observation mattered. Unlike objects native to our solar system, an interstellar visitor offers scientists a rare opportunity to study material created under completely different conditions. In many ways, it's like receiving a natural sample from another planetary system. As 3I, ATLAS moved closer to the Sun, astronomers expected it to behave much like an ordinary comet. Sunlight would warm its icy surface. Frozen gases would escape into space. A glowing cloud of dust and gas would gradually surround its nucleus. Some of those expectations proved correct. But the details told a more interesting story. The object released material in uneven bursts rather than at a constant rate. Jets of gas appeared from different locations across its surface, suggesting that its interior was far from uniform. Instead of melting evenly, different regions became active at different times. Scientists believe this behavior may be caused by layers of frozen material buried beneath a hardened outer crust. As sunlight slowly penetrates deeper into the nucleus, pressure builds below the surface. Eventually, trapped gases break through weak points, producing sudden eruptions that send dust and ice into space. This process has been observed in several comets, but every interstellar object provides a chance to see how these events unfold under conditions unlike those found within our own solar system. The discovery also invited comparisons with two earlier visitors. The first, detected in 2017, surprised astronomers because of its unusual shape and unexpected motion. The second, discovered 2 years later, behaved much more like a traditional comet while still displaying chemical differences linked to its origin around another star. Now, 3I, ATLAS adds another important piece to that growing picture. Each visitor appears unique. Each carries evidence of a different stellar environment. And together, they reveal that our galaxy is constantly exchanging material between planetary systems. Spectroscopic observations offered another valuable clue. By separating light into its individual wavelengths, scientists can identify many of the chemicals released from an object. Early observations indicate that 3I, ATLAS contains a mixture of frozen gases, dust, and carbon-rich compounds commonly associated with icy bodies. The exact proportions are still being studied, but every measurement helps researchers understand the conditions under which the object formed. In effect, this tiny traveler is carrying a chemical record from another corner of the Milky Way. That makes it far more than a passing comet. It is a messenger from another star. And as astronomers continue collecting data, they hope this remarkable visitor will reveal new insights into how planetary systems form, evolve, and scatter material across the galaxy. Because every interstellar object has its own story. And 3I, ATLAS has only just begun to tell its own. As astronomers continued studying 3I, Atlas, one conclusion became increasingly clear. This object wasn't important because it was mysterious. It was important because it was rare. Every interstellar visitor offers a direct glimpse into a planetary system that exists light years away. Instead of observing distant stars through telescopes alone, scientists suddenly have the opportunity to examine material that actually formed around another sun. That makes every measurement incredibly valuable. Researchers believe objects like 3I, ATLAS begin their journeys during the chaotic birth of planetary systems. As giant planets form, their powerful gravity can fling smaller icy bodies into deep space. Some are thrown completely out of their home systems, becoming lonely travelers that drift through the galaxy for millions or even billions of years. Most will never encounter another star. But a fortunate few eventually pass through planetary systems like our own. When 3I, ATLAS entered the Sun's gravitational influence, astronomers immediately began studying its composition. By analyzing the light reflected from the object and the gases released as it warmed, they could identify many of the chemicals locked inside its icy surface. Each molecule acts like a clue. Together, they help scientists reconstruct the environment where the object originally formed. Was it born around a young, active star? Did it spend billions of years in deep freeze before reaching us? Or did it experience close encounters with other stars long before entering our solar system? These are questions that only interstellar visitors can help answer. The discovery of 3I, ATLAS also highlights something remarkable about our galaxy. The Milky Way is not a collection of isolated stars separated forever by empty space. Instead, it is constantly exchanging material. Tiny fragments of distant planetary systems travel enormous distances, carrying dust, frozen gases, and complex molecules across the galaxy. Over unimaginable spans of time, this material becomes part of an ongoing cosmic cycle. Some scientists even suggest that organic molecules, the basic chemical ingredients needed for life, may be widespread throughout interstellar space. That doesn't mean life itself is traveling between stars. But it does suggest that many planetary systems may begin with similar chemical building blocks. Objects like 3I, ATLAS provide an opportunity to test those ideas using real observations rather than computer models alone. The object has also exposed one important limitation. By the time astronomers discovered it, the visitor was already passing through the inner solar system. There was no spacecraft ready to intercept it. No mission waiting to fly alongside it. Scientists could only observe from a distance before the object continued its journey back into interstellar space. That realization has inspired new ideas for the future. Several space agencies are now studying concepts for rapid response missions capable of reaching future interstellar visitors much earlier. If successful, a spacecraft could photograph one up close, analyze its surface directly, and perhaps even collect samples from an object that originated around another star. Such a mission would transform our understanding of planetary formation across the galaxy. Until then, telescopes remain our best tools. Every new observation improves our understanding of these extraordinary travelers. Every spectrum, every image, and every measurement adds another piece to a puzzle that extends far beyond our own solar system. Soon, 3I, ATLAS will fade into the darkness once again. It will leave no message behind. No signpost pointing toward its birthplace. Only a trail of scientific data that researchers will continue studying for years to come. But perhaps that is its greatest gift. It reminds us that our solar system is not isolated. It is one small part of a vast and connected galaxy where material from distant worlds occasionally crosses our path. Somewhere, beyond the reach of today's telescopes, countless other interstellar wanderers are already making the same silent journey. One day, another will arrive. And when it does, humanity will be ready to learn even more about the universe beyond our own star.